Hey, welcome back. Thanks for tuning in. So in this video, this is supposed to answer the question, hey Kirsch, what files do I put in my Gerber file list? There's so many films and all these pink things in OrCAD PCB Editor. I don't know what to put in there. Okay, so I will answer that. This is the full list, pretty much. Whether you're freelancing, doing professional work, you need this full list. Okay. And then I'll show you how to export your drill file. So what are we going to do? We're going to cover the artwork films for your Gerber, and you're exporting the drill file or making the drill file. So go to export if you're using OrCAD PCB Designer Professional. If you're using Allegro, you might need to go to manufacture and then Gerber export or something. I don't remember. All right. So go to export Gerber. And then go to General Parameters. You want to make sure your Gerber RS274X is selected. Personally, I like ODB++ and IPC 2581 format. But anyhow, so if you're doing Gerber, you want your output units to match your design preferably. It doesn't have to, but hey, put it in imperial units if you're using mils. But you don't have to. Anyway, make sure everything else, the defaults are set. That's fine. Under film control, what is film control? These are the layers of your design. That's it. Film control just refers to what you see. So let me show you. All of this right here, this is all of the films on your design visible, or all the, how do I say, layers visible. The films you create are what you generate. So what you're looking at isn't necessarily what you're going to export. The first film we look at is assembly details, right? So to generate this, you would do something like, if you've seen my other videos, you know the drill. You can click on any folder. You may have two folders in here already, and then you right click on a folder, choose add manual, call it, I don't know, Silkscreen top or something like that. Hit OK or enter. Then for the Silkscreen top, you go to something like manufacturing, auto silk top. If you've already done your auto silk generation. If you haven't done your auto silk generation, you go to package geometry, silkscreen top, and then also reference designator, silkscreen top. Then you click OK. And then if you right click display for artwork check, you see your silkscreen data, your content. And then if you want, you add other material on your silkscreen layer, but this is what you see. Okay, even though it's yellow and some letters and white and everything, what you see is what you'll get when you export it, right? Oh, and make sure you set your undefined line width. For really, really skinny lines that have no line width, zero line width, you want to change them by default to 5 or between 5 and 10 thousandths of an inch. Okay, we'll go with the minimum of 5. All right, so that's how you generate your silkscreen. That's the process. That's the way you manually add your layers. So let's say we wanted assembly details, right? What do? Well, first of all, let's cheat. This assembly details folder is already here, right? So what I'll do is add these assembly detail, assembly nodes, dimension, outline, blah, blah, blah. So let's do this. We'll call it assembly 2. Right click, add manual, assembly 2, hit OK, and then you look at things like, oh, can I click on here? No, okay. You look at things like, for assembly, your components. Assembly is about assembling components on the PCB, right? So you want to look at package. Now, what's package? Package is Allegro's or OrCAD's way of describing the footprints of the parts. They're called packages. Okay, and then we look into our package folder. We want the assembly top subclass of all our packages. We need that information. What else will we need? We might need, well, really, that's about it, huh? We also need a reference designator for the package, which is under its own folder. I don't know why, for just reference designator. And we have assembly top here. That's pretty much all you need. Let's look at it. So if we right click and display for artwork check. Yeah, I mean, it's pretty good. Now, if you're going all professional with it, which is sort of the purpose of this video, I mean, not the full thing. If you want the full stuff, you need to get my course. That's my online course that's coming up this year. All right. But anyway, if we look at the full assembly details folder and expand that, you have assembly notes, design outline. Actually, I wonder if I can. Okay. So you just right click, display for artwork check. We get all this stuff. You know, when you're doing it pro style, you gotta have your notes. You gotta say electrostatic discharge control, the IPC standards, you know, all that stuff. What else? Package geometry assembly top reference. Yep, I have those two. Drawing format, the outline, the dimensions. You know, for assembly, they may want to know your dimensions, or they might not. Definitely want the design outline and some assembly detail for sure if you're doing it, if you're going pro with it. But a lot of manufacturers will just take this. You know, if you're working on a hobby board. Oh, but we need the outline. So how do we add something if we forgot to add it, right? You have to click on the pink thing, right click, add. And let's choose the design outline. This has to do with the board, not the packages. So where do we go? We may take a guess and look at board geometry. And now which one, right? Of course you can check mark assembly, detail, notes, and whatnot. But the design outline, for sure. This is it. Now, in previous versions of Allegro and PCB Editor, this was just called outline. Outline covered both the design outline and whatever other outline, but they separated them. Sometime in 17.2 QIR whatever, a certain release, they separated them and made this new thing called design outline. So let's see. You don't want to include outline if you're using later versions of OrCAD. I'm in 17.4, so yeah. What else do we have here? Oh, I think that's good. Click OK. I'm talking too much. Let's right click, display for artwork check. Let's see, look at that. That's pretty solid. You got your notes, you got your outline, and what you see is what you get. So once you generate this film, this right here, assembly 2, all of this gets squished down like a pancake. All of this gets put on each other like a Photoshop type thing. All these come out as one drawing, all black and white, or one solid color. These all get mashed together into one drawing. Okay? But just take note, let's make sure our undefined line width, like this right here, this looks really, really thin, like 0 line width. So when we generate this, see, if we generate this as it is, these really skinny lines aren't going to show up. Well, like this one is not going to show up. We actually need to put 5 to 10 mils for the thickness of the lines, so that when the artwork is, or the drawing is generated, that turns into at least 0.005 of an inch thick, like this, and this too, you know. Okay. All right. So I belabored that. Hopefully you get the point. If you don't, just rewind and try it yourself. It really helps. Let's look at bottom copper. If we right click, display for artwork check, what do we need in the bottom copper? We need to etch along the bottom, right? Now where is that? Well, you can right click, add, and bottom copper. So that would be etch. Etch refers to anything that's copper. That's just what Cadence calls it. They call it etch, or OrCAD, whatever it is. They call it etch, okay? Anything that's copper, they call it etch. Etch just means copper. So if you select your bottom, then you click OK, it gets added. What, will it double add? No, it won't double add. Okay, so that makes sense. What else do we want to see the copper of? We want to see the copper of the pins that are on the bottom of the board. That's for your through-hole devices. So you right click, choose add. Where's the pin? You need to go to not etch. It's kind of hard to guess if you're not familiar with what printed circuit boards are actually made of. So it's really hard to guess. But you can click on pin, bottom, and there you go. And I don't have to guess actually. This word in the front is the class, and the word on the right is the word after the slash is the subclass. Okay. what are classes and subclasses? Well, I'll show you by demonstration. So we need to look at the via class. Right click, add. We need any vias. We need to see the bottom copper of any vias on the board. So click on this via class thing here, and then we need to select bottom in that via class. We don't care about the top of it because our drawing that we want to generate is called bottom copper. So we want just the bottom pad of any vias. And this bottom is the subclass of the via class. I know it's a lot. I hope I'm not confusing you. But anyway. Now once those are all added, you close your folder, you right click, display for artwork check. Oh, I'm already looking at it. Okay, so let me show you. Display for artwork check. Now you can also do display for visibility. What's the difference? I have no idea. Okay. I don't know. So it is the same to me. I don't know. All right, let's go to bottom paste. What is bottom paste? Paste has to do with, let's see if I can find a picture right here, right? Paste mask refers to, when you look at a printed circuit board, if it's not finished, like with some kind of paste, you'll see nice shiny, these will be nice and shiny looking exposed copper pads. But when it looks dull, like how this looks, this looks, it's a bad quality, poor quality image there. Anyway, this paste, it's sort of gritty. Just look up solder paste, you know what I'm talking about. You heat it up, you squeegee it onto the board, you heat it up, and then it'll melt and do the solder on there. So let's right click, look for paste, display for artwork check. Bottom paste, what does that mean? So if you have paste mask on the bottom, you're putting paste, solder paste onto the bottom of the PCB where you want to solder components onto. This applies to any surface mount components that you put on the bottom of the PCB, or any through hole components that you put on the bottom of the that go through the bottom of the PCB. I don't have any components on the bottom of this PCB. So let's turn on global visibility. Let's make sure we understand what I'm talking about here. All my parts are on the top of the PCB. I have some through hole components that go through the PCB. Let me show you. Let's take a look. All right, so we have visibility. Turn off the I'll remove my step 3 model, right? All my components are on the top of the PCB. I have some through hole components. If you hold down the shift key and the middle mouse button, I got this going on here. So when I put some solder paste on this copper pad to make it easier for me to solder this thing on here, let me see what else. I put some solder paste on the bottom of these pads where these through holes, like these pins, go through. I'm only going to see the round bottom parts of these for these through hole devices. So let me show you what I'm talking about now. Now when we look at the Gerber and we look at bottom paste, see? That's why we only see the bottom shape for the through hole. Okay. And make sure your undefined line width is set to between 5 and 10 thousandths of an inch. Alright, let's go to bottoms. So for bottom paste, how do we set that? We would use the package geometry, paste mask bottom. Okay. So you right click, let's say it was in here, you go to add, package geometry. Why package geometry? Because it has to do with parts. Package geometry. We might have a section of a part or a package that needs to be exposed and have paste put onto it. So we want package geometry. That's the class. Then underneath here we have the subclass. Paste. What is it called now? Mask bottom. Right. If I can just wait, what? Okay, there we go. Then we add that and click OK. For this, we right click, pin, paste mask bottom. So you right click, add, We're looking for pins now. See these pins here? Paste mask bottom. Click OK. Via. Vias have top and bottom parts to them. You know, look at these vias. But what's interesting is only certain vias would have paste mask on them. So, but I add them anyway. I add this anyway. So right click via class, add. Let's look at our vias. Via is vertical interconnect access. It's those little holes that you see on the PCB. Let me give you a good example. Okay, no. All right. It's really, it's a terrible picture. Oh man, it's really bad. Anyway, so see this via right here? There's some exposed copper on here. Now, I don't know why you would even need paste mask on a via. So, actually, I would take that out. But hey, if you want to take something out, you can right click, cut it. It disappears. So, bottom silkscreen. What is the bottom silkscreen? It's the same as the top silkscreen, but on the bottom. So, when you're adding your silkscreen, well, let's right click, display for artwork check. You go on your okay, let's do this again. So let's right click, add manual. Do not choose add. There's a specific reason for that. Add manual. Oh, no, what? No. Silk bottom or something. Click OK. And then what do we do? Well, you can do package geometry, silkscreen bottom. Okay. And then what else do we need? You click on the pink thing that you just added. You right click and then choose add. We also need the reference designator. So go to reference designator, silkscreen bottom. Click OK. Now if I right click and do display for artwork check for copper or something, right? That's fine. Now if I check for my new silk bottom, display for artwork check, look at that. Oh, and look at the polarity markers too. The pin 1 markers on the little circles. Let's make sure. Is that on the bottom? It is. Okay, so that's how you add your silkscreen bottom. Now, what about bottom solder mask? Solder mask is a little tricky, but let's do it. So, first of all, what does solder mask look like? Right click, display for artwork check. And why does it look like this? Why does it look like paste mask? Okay, let's explain this one. First of all, you need to understand what solder mask even is. It is a material that you see on a printed circuit board. It's what gives it its nice color, blue, purple, green, whatever. And it's this really resistive material that you cover all this copper with. Like if you peel this green off, all of this area, these lighter areas, is just copper. The darker areas are material under the copper. Let me show you. Let's see. See, like for here, for example, we have our solder mask on that green. The material under the copper would be like a pre-preg or whatever. Anyway, so when we peel off the copper, or when we peel off the solder mask, excuse me, we see copper. We cover this board of copper with the solder mask. We mask. And there are certain areas of the green film that are opened up, that are exposed, that are relieved. These areas that are exposed, they are carefully planned to match or overlap the pads and pins we want to expose. Because if you just have full solder mask and you put it all over the PCB, right, and don't open up anything, all of the copper is going to be covered. We can't solder anything we can't solder anything to the pins because they'll be covered like these traces are by the solder mask. So we need to relieve or open up or expose the solder mask, right? And if we were to make a positive view of this material, like positive being wherever we see the color in PCB Editor is where we see the actual material, then we would see color here, we would see purple all over here and the pads and everything, and we would see nothing in these gaps. We would just see gaps where the relief is supposed to happen. Okay, Kirsch, why are you talking about all this? I thought you were supposed to be explaining Gerbers. Why are you talking about this stuff? Okay, I'm getting to that. The reason I'm saying all this is so you understand what's going on material-wise. Because here's the thing. We can do it this way. Like Cadence could have made it so that we have purple showing up or green showing up for the solder mask material, and then gaps and black showing up for the relief, for the openings, for the exposed areas. But what they decided to do instead was by default turn this into a negative layer, so it inverts the view. That means we'll see colors, we'll see the purple color where we want to expose the mask. Okay, where we want to open up, that's where we'll see the color. So the inside here is going to look purple. Inside where these pins are going to look purple, and everything else is going to be black and void. That's what they did here. This was a negative layer. So all the black around here is where the solder mask is present. All the purple in the software is where the solder mask is not present, where it's exposed. Okay, really long explanation. You probably didn't need that, but you know, hey, it's whatever. So that's why it looks like this. Now, what areas do we want to see exposed? Let's make our own bottom solder mask. Let's do it. Right click, add manual. Bottom, well, okay, let me put Z, bottom solder mask. I put Z because it goes alphabetically. I want it to be at the bottom so I can delete these later. All right, we want, where do we even start? Okay, let's look at the package geometry. It's all about these parts, the packages, the footprints. So let's go to package geometry. And we definitely want to look for solder mask. What, we're on the bottom here? Okay. Solder mask bottom. Select that, click OK. Why is that? Because some devices for their package footprint will want big areas exposed, where they'll want the copper exposed. I don't have any examples here, but you know, those big MOSFET pads or something like that. They have gallium arsenide or silicon carbide MOSFETs with those big exposed pads. Yeah, something like that. Anyway, so there's that. What does the view look like? Display for artwork check. Nothing shows up because I have no parts that require opening large like that. All right, let's add some more things. Right click, add to our solder mask bottom. We need to look for pins. Okay, pins that need to be exposed. All the pins need to be exposed. So solder mask top. Oh, no, excuse me. Solder mask bottom. Click OK. Why isn't it showing? Well, we have to right click, do it again. Display for artwork check. Ah, fantastic. That looks great. Now here's another thing. We're done, right? I mean, these are all the parts, right? Like, well, that should be it, but it's not. It's not. It depends. Let's look at these vias. The vias are covered in solder mask, which means we're not going to expose any of the vias. We're not going to expose them. If we're doing this PCB down here, so that's what they may call tented or plugged vias, whatever it is. Some manufacturers don't want you to cover the vias though. So if you have some vias here or whatever, they're covered by the solder mask. They're covered by the black. What if the manufacturer says, hey, you can't do that? Well, you need to go to, you need to expose the via. You say, oh, Kirsch, how do I do that? Well, this is how you do it. You go to your folder and say, you right click on the pink thing and look at your via class. And subclass, solder mask bottom. Click OK. Now, I wonder if that'll even show. Let's right click. Display for hardware check. Aha, there we go. See? All the vias exposed. See, they can't hide now. There's nowhere to run. Alright, so move that out the way. Now that we have all the artwork, let's see. Well, we don't have all the artwork manually being added, but I showed you so we can understand the process. You have things like fabrication. I'm not going to do all this. Just take some screenshots or whatever. Pause the video, take some screenshots. This is the list. Okay. You add that. Next, we have photo plot area. You want to go in your class, then subclass. Your class manufacturing, subclass photo plot outline. So when you right click display for artwork check, this is the area that outlines just the PCB. Fabrication, display for artwork check. This is where you put your drill, your stack up information. See, you do all this stuff if you don't have like a documentation software or something. But luckily, I do have one. And if you have a CAM engineer, they have the documentation software as well. But anyway, I'm getting sidetracked. So now let's look at the top solder mask. If we right click display for artwork check, you know the drill, right? Now here's something very interesting. These are all the, let's look at this. We have the via class, right? All the vias, they're exposed for the top solder mask. The pins, they're exposed, top solder mask. Package geometry, solder mask top, our top solder mask. That's for our footprint. See this special footprint right here? I put this here in such a way that, yeah, this is the regular pad underneath the footprint. But here, I put some dots in the footprint definition where we want to put, we just want to put those dots there. Or really, maybe that should be paste mask. I'm not sure. Anyway, that really should be paste. But anyhow, run with it. It won't make a difference. It works fine. Okay. And then we have the solder mask top for the board geometry. Well, what is this? This is this is specific to the board. If there's anywhere on the board where we just want to expose some copper, let's say over here or just somewhere, just willy-nilly, we can just find somewhere on the board geometry where we want to draw a shape, something, in the solder mask subclass of this board geometry class. We draw a shape and say, hey, we want to expose this area because we want to see the copper because, you know, we're weird like that. And then that's what you see. That's what you do. Okay, now top copper. Right click, display for artwork check. This is the copper we see. What is in this category? Etch top. Remember that Cadence calls copper etch. Okay, it calls it etch. I don't, because it etches the copper. And then pin. Any pins, we want to see the top of those pins. The copper top of those pins. And then for the vias, we want to see the vias as well. Just keep in mind that all we're doing here, we're using a software tool to make drawings. That's it. There's no inherent intelligence. This is Gerber, which is just a bunch of text files that tell you, hey, draw these lines. And then the manufacturer figures it out. So there's not much we can do here in terms of intelligence for this stuff. It's just drawing. So what it said is we have to define exactly. We need to look at our vias. We need to look at the top of the via. And then there's the bottom of the. Okay, that's why we're doing it this way. And then you squish all of these different layers together and they make one drawing. And there you do. Okay. For the right click, display for artwork check, top paste. I think we talked about paste mask already, but let's look at this list. We want package geometry, paste mask top. package geometry, solder paste top. Okay. If you have any questions about these specific layers, just leave them in the comment section or email me. And then pin paste mask top. Any pins, we want to see any solder paste that needs to go over here. Now this is a positive artwork layer. That means in this situation, what you see is what you get. You'll have some, these don't look like they have solder paste on them, but let's pretend that they do. And so these pins, these pads, they don't have solder paste, but we were pretending. Imagine that there's a little bit of gray paste, solder paste on here that's squeegeed onto the board. We see in the drawing where we want the paste to be. So this is a positive artwork layer, whereas solder mask gives us the negative view. Okay. Pin via class paste mask top. Yeah, that's still weird to me, but anyhow. Okay. Don't know why I have it in there. Top silkscreen. Right click, display for artwork check. This is your top silkscreen. What does this consist of? Well, it is your board geometry silkscreen top. Why board geometry? I thought we were talking about packages. Didn't we discuss packages earlier for silkscreen? Yeah, but you know, hey, you may want to add a little bit of, I don't know, your company logo, something that says, hey, like, Gersh was here, or something like that, you know. And why isn't it showing up? Why isn't it showing up, right? Because I didn't put it in the right active class and subclass. So if I right click done, it doesn't show up. Because I'm looking for, right now I'm looking for top silkscreen with only these layers. Uh-oh. So what do? I can either add the text for that class and subclass that I don't remember. I don't remember the class and subclass, I just added them. Or I can force the text to be a certain class and subclass. So that's what I'll do. I'll turn global visibility on. Change this, right click from, I'll change this layer to silkscreen top. Sure. Change to layer silkscreen top. I don't even know what layer. Oh, board geometry silkscreen top. Ah, okay. This will show up. Right click. Change to layer board geometry silkscreen top. And so then it's going to show up. And I'm going to repeat this process in case it got confusing. So now when I right click, go on my Gerber or go on my menu, go on my Gerber, and then do top silkscreen, right click, display for artwork check, it shows up because see, it already defined board geometry silkscreen top, and this text is in that class. Fantastic. Next we have manufacturing auto silk top. There's a whole process behind that. I won't get into it. Just ask me, or I'll send you a link to a video where I do the auto silk top process. Then there's package geometry silkscreen top. Package geometry silkscreen top. Yeah, that's pretty good. Package geometry silkscreen top. I took advantage of the reference designators that are on there. But you know what? I really should have added this other thing. Let's right click, click add, and go to reference designator, silkscreen top as well. Well, actually no, I shouldn't necessarily have added this because it's included in the auto silk top already. So we don't even have to do that. We don't even have to add the individuals because auto silk top takes care of a lot of that stuff. Again, auto silk top it's involved. You have to, I'm not going to do it here. All right. After all that, let's make sure that all of our layers have the undefined line width set to something that you're satisfied with. Maybe 0.006 of an inch or for your default line widths, right? This is for undefined line widths. All of your line widths that are defined with a certain thickness, they're going to be printed out in whatever thickness they are. Now, what else do we have here? I'm going to cut out these layers that I added so far. If you want to remove a layer and start over, you just right click cut. Right click cut, right? Fantastic. Next, what's the next step? The next step is to go to your apertures. Go to apertures, edit, auto without rotation. Your list will be empty by default if this is the first time you're doing it for your specific board. And then it'll populate, you wait for that. It'll let you know how many apertures were added. You click OK, then you click OK again here. Then, now that they're added, you can, you may have a thing here where you need to update your DRC and update shapes or whatever, so you make sure you do that. And then finally, moment of truth, you choose select all. We want to select all of our artwork film layers and then choose create artwork. Then it gets generated. You'll get some warnings, especially if it's your first time. You want to look at the warnings. Film contains objects with associated DRC. You see, it doesn't like these DRCs there and whatnot. But in general, you want to look at the bottom, look at the summary. It says all these were created with warnings. Yeah, artwork had warnings. It'll let you know if you had an error as well. And this is the view. Now, if you close this window by mistake, you can always click on view log and it'll show up again. What else do we have here? Something very important. Oh my goodness. Where I talked about solder masks so much. Actually, this is pretty okay. It's for your plot mode. The plot mode refers to what you see. If you want, you can make your plot mode negative. That comes out looking very interesting, but it conveys the manufacturer will still be able to interpret it once you let them know which layers are positive and negative. Okay, but leave everything positive. All right. And also another tip: people talk about, I've seen people talk in online forums and whatnot, the difference between positive and negative layers. You know, what do I go with? And yeah, you'll save some space if you go with negative layers, but it's literally like no difference. We're talking about kilobytes of space. Okay. All right. Do we care about seeing full contact thermal reliefs? Do we want to suppress unconnected pads? It's up to you. That gets into more details. All right. Now let's say you want to generate the PDF for this. You would select which layers get printed in which order based on this number here. You can move it up, you can move it down. Okay. I'm going to keep it as is. All right. Now, those are the artwork in general. Click OK. But the artwork is not the end of it. You need to generate your drill. So go to NC drill, then go to parameters. Then you'll have your parameter file. The default file, just leave it alone. Don't touch that. You can have your header say, hey, you know, Kirsch's main design header, generic thing. Your leader, make sure you have the ASCII code if you need EIA for some reason. I don't know, do your EIA there, it's up to you. Make sure you have leading zero suppression and then enhanced Exelon format, very important. Very important. Or just go with whatever your company tells you to go with. But if you don't know what to do, go with these settings. Just click OK. All right, the root file name. Yeah, just leave it as is. Now, if you want to double check and make sure, you can click on your ellipses and set the folder, but just leave that like just leave it alone. Hit number 1 for the scale factor, very important. Okay. Now, if you know what tools, let's say you have a tool table already, like you have a special machine shop or something, you can auto tool select, and then it'll auto select the tools based on the hole sizes that are in this design. But I don't turn that on. Repeat codes, you can do that. For certain milling machines, repeat codes actually messes up the drill file. So yeah. You can have separate files for plated and non-plated holes if your manufacturer takes separate files for them. I know 4PCB.com does. This isn't sponsored, I'm just saying it. That's what I use a lot. Sierra Circuits, PCB Way. But I just leave it alone. Optimize drill head level. Okay, if you care about that, don't worry about it. You can hit the help section. It is really helpful to understand more of these. Okay, layer pair or by layer for the drilling. Ask your manufacturer, but go with layer pair. These settings by default are pretty solid. Now, let's go to, did I do that? Parameters, yeah. Hit drill. And usually you get no errors with the, but here, see, pay attention to this. Design, you have your command window open. If you don't know where to find your command window, you need to go to display, windows, turn command window on. Always keep this open. Why? It gives you very important messages. It's equivalent to the messages window in Altium Designer. NC drill or design contains slot holes that cannot be drilled. See, I'll cover that. This is a long video, isn't it? Anyway, I'll be done soon. Click close. And then you can do counter drill, back drill if you're doing impedance control design and stuff like that. So let's go to export. What is this slaughter? What are these slaughter holes they're talking about? Let me show you. It's talking about this device. See, this doesn't have the normal standard. What's going on here? Why are these shaped so weird? If you have a drill bit, I used to make PCBs on the CNC milling machine. Okay, so if I had a drill bit and tried to do this, it would break immediately. Okay, if I drilled it down here and tried to, and it told the machine to move it this way, or if I put the wrong bit in the routing instruction, it would break the drill bit immediately. And the drill bits are expensive. Let me tell you, I'm talking about $25 to $125 per drill bit. Okay, it's expensive. So what do we use to drill this out? Okay, let me show you. We use what are known as router bits. Router bits are more like flexible and strong. Let's go to export. If you have slotted holes like these, you need to generate a route file. And this is, I think this is the last file we need to create. So root file name, just leave it as is. It has a .rou extension. Root feed rate, hey, only put this in if you know what machine you're working with. Okay, if you really have tight control, you almost never have to fill this in for a manufacturer. Separate files for plated and non-plated routing. We leave it as is, it's okay. It doesn't apply to me. We go on our parameters again, make sure the settings are as is. Okay. And of course, don't forget to change your units, your chord, you know, if you're working in metric, you know, do metric. So yeah. And then you route. Fantastic. NC route completed successfully. And you can do the view log to see what happened exactly. Also, where do you find the folder or where this was routed? It will show you. Huh, it will not show you. Okay. Anyway, it'll route it in the same folder you did your drill thing. Okay, so if you go to export, NC drill, view log, then it'll tell you drill files, output directory, C, blah, 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 hardware completed. Yeah. Okay, there you go. Fantastic. That is how you generate your Gerber and drill and route files. Now, how do you package them together? I'm gonna open my folder and show you. Let me navigate to the folder. I'm just gonna hum while I find the folder here. I don't want you to see all my projects. I don't have that many projects, but I'll just say I have projects. So hardware, maybe. Okay, cool. This project is from a course that I've been working on. I'm going to shamelessly mention that course. It's not done yet, but it will be soon. So let's go to, oh, we've got an artwork folder. Look at that. Huh. This guy. Look at how organized I am. Oh my goodness. It was not this case like 2 months ago. But anyhow, so we have the art files. This is very important. You want to select the art files, the .art extension, and that's it. The .art, 1 extensions are not art files. Don't use them. You want these. You also want your .drl, and you want your you have 2 DRL files if you did plated versus non-plated holes. Non-plated usually for non-plated mounting holes. And then you want your route file. Where's your route? Yeah, see? Control, select this. You want your .rou. Then right click, 7-zip, or send to compressed zip folder. Give it a name. Special Gerber and drill and route. Then you submit this zip file to the manufacturer. Make sure the zip file does not have a folder within the zip folder. It's just the raw files, especially for PCB.com or PCB.com. Okay, that is how you generate your Gerber and drill files. I hope this video has been very helpful to you because I spent like a long time working on it. It's not that long, it's just been 46 minutes. But this is generally how long it might take, okay, for generating Gerber files. I recommend if you have a Gerber viewer, especially a free one, get a free Gerber viewer and then look at your Gerber files to check them yourself as well. Because when you submit it and you're waiting on feedback from the manufacturer or the DFM tool, you just want to see for yourself why it might have errors. Be able to assess that. That's how you learn. Okay, this is the end of the video, and keep designing. Bye.